The customer class has three constructors. Now keep in mind that these are special forms of methods with the same name as the class. The .NET Runtime executes a constructor when instantiating an object in order to perform actions required to create the object, such as to set initial property values, open a connection to a database or a handle to a file, or whatever else might be necessary, if anything. So the first constructor it has is an empty constructor. This builds what is basically an empty customer object, ready for you to set property values. This form of constructor is not really needed because the compiler always creates an empty constructor for you if you don't. Now I've included in the code here in order to make it clear that this is always a part of a custom class. The second constructor is one that takes as a parameter the ID of a customer. This option is typically used to let you retrieve an existing customer's data from a database or some other persistent storage, and automatically populates the object with that data. In the sample application that I'm going to be showing you, it creates the object and only sets the customer ID value. So then calling code needs to set other properties as necessary. And then the third constructor is a constructor that takes as parameters all of the information for a customer name, location information, and so forth. This is a handy way to fully populate the data for a customer object in the same statement, a single statement, that instantiates the object. Now, the design and number of constructors that you include with a class is going to depend on how you'll want to typically use the class and specifically create the class. It's quite common to have 2 or 3 constructors, and more complex classes, or classes that will be used in complex ways, will often have more. And many classes will have no explicit constructors at all, meaning that you'll only have the empty constructor. All right, and then the customer class also has several methods. So these are not constructors. These are not part of building the object in memory, but are instead used once the object is available in memory. Or if they're static, you can use them directly on the class. So the first one is getCustomerInfo. This method takes as a parameter the ID of a customer. It then searches for an XML file containing the customer's information. If the method finds the file, it reads the XML and sets the value of various properties of that customer class. There's a saveCustomer method. This takes as a parameter an instance of the customer class, so a fully hydrated customer object. And then it creates an XML file containing the customer's information. The method reads the properties of the instance of the customer class and writes those values out to the XML file. Next one is getLocation, and this method takes as a parameter again the ID of the customer. The calling code passes this by value. And the method also takes as a parameter 4 empty string variables, one each for the customer's city, region, postal code, and country. So the calling code passes these by reference. And then the method then searches for an XML file containing the customer's information. If the method finds that file, it returns the customer's name and sets the value of the other parameters to the appropriate information from that XML file. So we're starting to get into some fairly complex actions here. And then finally, there's a recordSales method. This method takes as a parameter the ID of the customer again, the dollar amount of annual sales to the customer, and the number of units in orders placed by the customer. So some arbitrary order kind of information. And the method writes the information to an XML file. Okay, so I'm going to be talking about each of these kinds of methods in a little bit more detail and showing you a lot of code and how they're implemented within the sample class. All right, so let's start by talking a little bit more about constructors. As I mentioned, every class requires a constructor. Because in order to create an instance of the class, the .NET Runtime needs to execute code within the class that actually causes the object to load into your application's memory. Now, as I also mentioned, you don't have to create a constructor in your class. If you don't, the compiler will create one for you. Constructor will be empty and won't take any parameters, and the code will look like this. So this is for a customer class. Constructor has the same name as the class, takes no parameters, and the body has no statements. That's the empty constructor. Many classes in the .NET framework have empty constructors. And the string class is an example. When you first create a variable using the string class, that variable's value is string.empty. It's up to you to supply the variable with the value. So a lot of times your own classes won't have constructors as well. But probably a lot of the times they will, because constructors can do very useful operations on the class. And then the .NET Framework also has classes that require you to pass an argument to the constructor, and they throw an exception if you don't. The FileInfo class is an example of that. It contains methods for working with a particular file on a disk drive. The class requires you to pass as an argument the full path and name of the file that you want to manipulate. If you don't pass that argument, then it'll generate a compile time error. When you design your classes, you need to decide whether the class needs a parameterized constructor. You can make your decision based on the behavior that's going to result. For example, here is some code that creates an instance of the customer class using the empty constructor. It then sets the value of various properties with information about the customer. So I'm not initializing any of the properties of this class, of this instance of the class, through the constructor. Instead, I'm initializing the values after I have the object in memory by assigning properties or values to the various properties. Now, how do I know that this code is using the empty constructor? Well, there's two ways. First, this statement right here doesn't pass any parameters to the constructor. And then second, if we look at the code for the customer class and find the constructor that doesn't take any parameters, we'll see that the constructor method body is empty. So if I come over here, Solution Explorer, and open up customer, I can see here's the version of the constructor that takes no parameters. It has an empty body. This is the empty constructor. So this is the one that's being used by this part of the code. All right, so when it creates this customer object there, so this instance represents a generic customer. It doesn't represent a specific customer because it has no information associated with a customer yet. All right, so the instance represents a specific customer only after the various properties are set. And so now it represents Biggie Industries. Okay, so you can kind of conceptualize this through a discussion between two employees. First employee says, "We just got a new customer." Employee 2 says, "That's great. Who is it?" Employee 1 says, "It's Biggie Industries. They're in Redmond, Washington, and their postal code is 98052. So that's kind of the conversation that's going on to create this here. We have a new customer, and then we gather information about it. Now, when designing the customer class, you may decide not to support the scenario. After all, you can't make a sale or collect money from a generic customer. If you're adding a customer, you need to know who they are. Okay, so you can look at the code over here in customer, and here's another instance of a constructor. And this is the one of the constructors that I talked about earlier, that receives or accepts as parameters all of the information about a customer. Customer ID, customer name, city, region, postal code, and country. None of these parameters are optional, and so the calling code, when they're newing up a customer object, in order to use this constructor, has to pass in 1, 2, 3, 4, 5, 6 parameters in order for this constructor to execute. All right, so now this conversation goes more like employee 1 says something. Biggie Industries is now a customer. They're in Redmond, Washington, and their postal code is 98052. Employee 2, that's great. And so if I come back over here, this is the code that represents that conversation. In a single declaration, I'm passing in all of the information to the constructor. As a result, this new customer is fully hydrated with all of the information about that new customer. Okay, and then in both cases, I have some console write lines that comes out and reads different information, displays it about the customer. So pretty much identical code there. And it's important to understand that the new customer here, this object instantiation, is going to be identical to the object that is in memory when I reuse that variable for a new instance of customer. So in this code, I've instantiated two different customer objects, taking up two different chunks of memory, but I'm using the same variable to reference them. And the structure of them, because I'm passing in the same information, is going to be identical. The only difference is whether the properties are set after you create the instance or while you create it as part of that more fully featured constructor.